Hey everyone, thanks for coming to the second webinar in our series of smart contracts. The first webinar obviously called Smart Contracts 101, so we're just keeping it simple and calling this one Smart Contracts 102. We see that there's a few people still kind of joining us here as we get started, so we'll just hang tight for just a minute, but just to recap from last time, during Smart Contracts 101, we basically just went through the basics of what blockchain technology is, what a smart contract is, and then we went on to Remix, which is a website and interactive development environment online that allows you to write your own smart contracts, test their deployment, and see how the functionality works. And we were able to deploy our first smart contract, which was pretty cool. And I think today we're going to get into a little more detail, specifically with the smart contracts and how to write them. So the agenda for today, we're going to be going with a use case that maybe is a little more familiar and more relevant to the real world. We're going to be talking about how we can basically convey a decentralized company through a smart contract. We'll be using Ethereum and the Solidity programming language once again. We're going to go over some concepts such as mapping and access specifiers, and Pratik will be introducing us to that. I'm Justin, by the way. I don't know if I ever explicitly said that. And then going forward, after that, we'll kind of go over the smart contract development timeline, kind of like the life cycle of going from idea to implementation. And Hoyan will bring you that part of the presentation where he'll go over aspects such as functional testing and performance testing. And then I'll come back at the end to take you through BlockTEST testnet and give kind of a live demo of exactly how you would go about submitting to the testnet and getting some results with like performance metrics, and that will kind of fit into the performance testing component, which Hoyan will talk about. So yeah, to start, I think I'm going to hand it over to Pratik, and he'll talk a little more about the use case of building a decentralized company.
Thanks, Justin. So we're going to start with a use case of a decentralized company. I'm Pratik, by the way, and I'm here at BlockTEST as a blockchain engineer. So if you want to have a decentralized company, how would you want it to be? You would want it to be transparent, and also everyone should be able to see the company's rules. It should be clear, and there should not be any modifying that such that the previous rules can be changed in the future. So the most obvious solution that comes to mind is blockchain, which has all these functionalities inbuilt. Now, in order to do that, we would want to have a Solidity contract, which is just a smart contract on the Ethereum network. So to start with that, we would want to define a version that we are going to use for the contract, and we are going to stick to version 0.4.25, same as we did in the last session. And we are going to call this contract company. This would also have a variable called address, and we would name that as owner. This is just to store the address of the owner. Now, address is nothing but an ID. You can just think of it as an ID, and this is used to identify a user or a smart contract on the Ethereum network. Now, to get our first functionality in, we would want to store the owner's address in this variable. And we can do that using the message.sender method. And with this, we will be able to store message.sender to the owner. And in this instance, as we are the one who will be deploying the contract, the message.sender will be our own account. We would also want to have some function in the contract because it doesn't make sense otherwise. So we will first add the functionality to add a new employee. And in order to do that, we would need to have the address of the employee. So we will define a function called add employee, and this would take an address, and the name of the variable is employee. But you might notice there is an underscore in front of employee. This is just a naming convention, and it is generally used to differentiate it from global variables such as owner, which you can see right inside the company contract. And in order for us not to be confused with these different kinds of variables, we want to use an underscore for the parameters that are used inside the function. Now, we want this function to be accessible publicly. This is to say that anyone on the blockchain has access to call this function. So to do that, we are going to introduce a new access specifier called public. On Ethereum, by default, the access specifier is public, but it always makes sense to write it explicitly so that it is more readable to other users on the blockchain. But we do run into one problem here. If it is public, it is accessible to everyone on the blockchain. But when you think about it, the owner should be the person who adds an employee to the company. How do we make sure that this is happening? To do this, we are going to use the require function. This is an inbuilt function where the first parameter does a check, and if it is true, it lets the subsequent lines of code in the function to be executed. If it is false, it just throws an error. And we also have the option to specify an error message, which is the second parameter. So in our example here, we want to check whether the message.sender is in fact the owner or not. This will make sure that only the owner gets to add a new employee to the company. And in case the sender is not the owner, it will just throw an error, and we will see an error message saying adding denied. This can be customized to whatever we want. This is just an example. Now, we do have this function, but the problem is, how do we keep a track of the different employees that are there in the company? So to do that, we are going to introduce a new data structure in Solidity called mapping. This is similar to a dictionary, and it uses key value pairs to store data. In our example, we are going to use address as the key and a Boolean as a value. A Boolean is just a true or a false value. Now in Solidity, everything by default is set to 0, which is to say all the addresses will be 0 and all the Booleans will be 0. But we do not have to worry about that, as we just need the Boolean to be true for an employee of the company. We will see that in the subsequent slides and how to do it. In order to add an employee, we are just going to add this one line of code in the add employee function, and we are going to say is employee, which is the name of the mapping, and we are going to pass the address parameter that was passed into the function, and we are going to set this as true. All this does is, in the variable is employee, the mapping for the address of the employee is set to true. So with this, we can actually check who is an employee of the company and who isn't. And this functionality to add employees is only available to the owner. Now, on this slide, there are a few other examples. And if we add some address, say this, for example, and we query is employee with the same address, this returns true. And on the other hand, if we use another address which is not added and we try to query this, this will just return false. This is just to give you a better example and understanding of how mappings work in general. Now, moving on, we also need to do a little bit of refactoring, because technically the owner is also an employee and he might want to be in that dictionary of is employee. So in order to do that, we don't have to call the add employee function. We can just do this in the constructor itself. So the constructor is called only the first time the contract company is going to be deployed. So when the owner account is set, we can also add the same line that we have added in the add employee function inside the constructor, which will add the owner's address as an employee. Now we probably need another mapping because right now we do not do a lot of functions. We just have a list of who is an owner of the company and who are the employees with the company, but they do not have any functions. Let's give them a function. So we will try to give the employees an option to add the number of hours that they have worked in this contract. So to do that, we need to specify another mapping, and we are going to name it employee to hours worked. This is going to be similar to the previous mapping with a slight change that we are going to be adding the employee's address to the number of hours, which we are going to define using uint. Uint is just unsigned integers, and we can have numbers which are very large. As long as they are not decimal places, we can use uint safely to store the value. This variable should be private and not public, because it makes sense that the hours an employee has worked should not be accessible to everyone on the blockchain. So we will be adding a new access specifier called private, and the employee to hours worked variable will be set as private. But if this is private, how do we access the number of hours anybody has logged? To do that, we need another function. As the access specifier is private, we will have a new function called get hours logged, and this would take in an address parameter called employee again. This is a public function and which returns the uint. It is the same data type as the value mapping of the employees to hours worked. Now inside this function, we are going to make sure that the right person can access the hours worked for the right employee. And in order to do that, we are going to again use a require, and we are going to check that the message sender is either the owner or the employee himself. If the sender is not the owner, or if the sender is an owner, is an employee, but he's trying to access the records of some other employee, we should not give them access to that. So this will ensure that it is happening as we expect it to. And after this, we are just going to return employee to hours logged and pass the parameter employee into this. This would give us the number of hours that the employee has worked. Now, this function does not do any change to the storage. We are not changing any data at all. All we are doing is accessing the employee to hours worked and returning it back. So it makes sense to specify a view as well for the function. This is very important because generally functions require gas to run on the network. But if a function is defined as a view, it does not need to be part of a block as a transaction. So it does not require any gas. It is a free call. Now, we need a way for the employees to log their hours. We are getting the hours back, but how do they add it? To do this, we need the last function of this test contract, and we are going to call it log hour. This is going to take in uint hour as the parameter, which is the same as what we need for the mapping called employee to hours worked. This will just make sure that the person who's trying to access this log hour function is indeed an employee of the company. And to do that, we are going to have a require, and this is going to check if the message sender is indeed an employee or not. If it is called by anybody who is not an employee of the company, we are going to throw an error saying log failed, not an employee. And finally, if he is an employee, the employee to hours worked mapping will be updated for this employee to whatever hours he or she specifies. As simple as that. Now, what is the next step? We have a simple contract ready, and we have the functionality that the owner could add a new employee. The number of hours logged can be viewed by the owner or the employee himself. And finally, the employee can add their own hours that they have worked. But is this ready to be deployed? In order to go through the timeline for the smart contract development, I'm going to give the session over to Hoin, who would go over the next steps.
Right. Thank you, Pratik. As Pratik said, yeah, I'm Hoyen, and I will be going over the smart contract development timeline. So in order for an idea to become a reality, in this case, for our smart contract to be deployed on an Ethereum network, we actually need to go through a couple more steps. So far, we've been going through the basics of writing a smart contract, which should be enough to get you started. But there are actually a lot more resources out there that can help you write better smart contracts. So aside from this webinar, you should probably be also checking them out so you can become a better developer. But after writing smart contract, we realized that once the smart contract is deployed, you cannot change it. And that's one of the major features of blockchain. And what that means is this smart contract should be thoroughly tested before deploying so there are no unexpected results. So functional testing becomes an important step before you need to deploy your smart contract. So how can we do functional testing? Well, traditionally, each main contract will be first deployed on a testnet. So what a testnet is, it's a simulated environment of blockchain. For example, on the Ethereum testnet, you will need Glass to deploy and run smart contracts. And since its purpose is for testing, the ethers are given out for free and they hold no monetary value. So for each contract, you would need a corresponding test contract. So after the contract, the test contract is written, you can deploy it with the main contract. And on the testnet, you can call the test contract to see if the main contracts are behaving normally. So the test contract we've written for company.so looks a bit complicated. So let's break it down. So in the beginning, you will notice we use the keyword core import. What this basically does is it allows us to use the code from that file, which is company. And over in contract, we can see contract test company is company. So what the is keyword symbolized is inheritance. So to inherit from a contract is to basically copy and paste the code from that contract to a current contract without actually doing so, which makes the code really clean and makes it really easy to organize. So in order to inherit the code from company, you just say is company, as simple as that. So yeah, in order to test each function that you write on the main contract, you will need to declare a test function for each method. And as you can see here, we have test add employee, test log hour, and test get hours log. Well, more specifically, you will need to call those functions that you want to be tested on this test contract. Thanks to inheritance, we are allowed to do that because in the test contract, we have all the access to the functions in the main contract. And as you can see here in the red brackets, red squares, we called add employee, get hours log, and log hours somewhere in each method. in each function. And yeah, basically that's it. This is a really simple and a valid test contract that can be submitted to a testnet. And here comes step 3, performance testing. So after functional testing and after we make sure that the code is bug-free, we probably want to test it in a simulated environment, because by putting it in a simulated environment, we can improve our code and see if there are any high-level logic flaws, and which would give you an edge over similar smart contracts and avoid potential bottlenecks. Say if there's like a function you define that actually takes longer than you expected, you can go into it, rewrite it, and see if you can make your contract more efficient and cost less fees. However, when we are trying to find a reliable tool for smart contract performance testing, we couldn't find any. So in BlockTEST, we thought, why don't we just make one? And that's how BlockTEST testnet was born. So the way how BlockTEST testnet works is we have a testnet dashboard where the user can submit their code and test file. And behind the scene, we would mock a blockchain environment where we create our own blockchain from scratch. And we will monitor each performance statistics of how that smart contract performed on this blockchain. And after that, we will give you data visualization of how everything did, and the user will be able to see it. So really, the user you need to do is to submit their code and their test files, and they would have to wait a bit and get their report on how their smart contract did. So in order to run testnet, unfortunately, you will need to write extra code, but you already wrote it. In the development, smart contract development lifecycle, all you would probably need to write a functional testing before you go into actually deploying the contract. But all testnet requires is that functional testing file, and you already wrote it, so you don't really need to do any extra work in order to submit it to BlockTEST testnet. So just a quick recap of what we went over this in this webinar. We ran over the concept of this constructor, which is a function that's called once when the contract is deployed. We went over naming conventions, which basically says you should add the underscore before parameters into functions. We went over mapping, which are basically key value pairs, and you can look things up. And if you're familiar with other programming languages such as Python and Java, they correspond to dictionary and hash maps. We also went over the concept of inheritance. Basically, it allows you to use code from another contract. And we went over access specifier, which says who can control and who can access this variable and function, such as private and public. And we also went over function specifier, which in this case we talked about view, which is a kind of function specifier that tells us, oh, this contract only reads and doesn't need to store any information, and it does not cause any gas. We also went over functional testing and performance testing. So functional testing makes sure that the code is bug-free, it works as expected, and performance testing would place the code against a simulating environment, and you could help us find some high-level logic flaws and help us find any potential vulnerabilities. So why should you use BlockTEST testnet? Well, compared to a traditional testnet, it's a stable environment. It's our own environment, so there are no external factors as opposed to a public testnet where there are factors you can control. And there are weekend testing variables that are impossible to control in a public testnet. Suppose we want to see how our code perform in a really high workload and when there are a lot of transactions going on. In a public testnet, this would be impossible because everyone have access to it and you can't really control what everyone's doing. But in BlockTEST testnet, you will be able to do that. And not only that, you can simulate your smart contract and how their performance is at different network sizes, which is also impossible to control of in a public testnet. We also give out data visualization on performance metrics. So all the testing variables that we talked about, such as workload, network size, throughput, and latency, you will be able to see that on BlockTEST testnet. And as those variables changes, you will be able to track your CPU and RAM usage, which can further give you information on how you can improve your smart contract. It's also really simple and safe to use. BlockTEST testnet has a user interface where you can just submit a link and fill out some forms. And afterward, after we test the smart contract and use their test files, we will destroy our testnet, the testnet environment that we set up for you, and we don't store your code anywhere in our database. So after we talked about so much about the benefits of our testnet, Justin will give you a guidance on how to submit your file on testnet and give you a demo on what you can see on our dashboard. And yeah, here.
Cool. Thank you, Hayan, and Pratik as well. I'm going to now take you through the actual dashboard itself and show you exactly how the submission procedure would look. So this is kind of like the homepage for our dashboard, where we basically list out a bunch of different problems that you can potentially solve. You could also submit code for your own solution if you had that as well. But here we're talking about the company, and we want to create a decentralized company. So since we're in here, we'll just go ahead and select New Submission from the drop-down menu on the left. And you'll see a screen that pops up where you just need to start filling out some information. So we'll call this submission company demo. And you see here it asks for a repository link. That's for GitHub. That's a GitHub repository link. Once again, as Hoya mentioned, rather than having you upload your code, we just ask for a link to the repository so we can pull the code and then get rid of it once we evaluate it through our testnet. So we just provide the repository link here and continue. Here we'll choose a blockchain platform, and for this demo, we will just choose Ethereum. And so now we have to configure the smart contracts within the platform. So for the language, since Ethereum contracts are all written in Solidity, Solidity is the only option. So we'll go ahead and select that. And then here you're gonna be asked to provide the path to your smart contract directory. So the way the testnet works, it basically requires all smart contracts to be inside the same directory path, inside the same folder. So if you go back to this repository, you can see that these contracts, they actually aren't in any directory. They're in the root directory right now. But they're both in the same folder, company and test company. So to specify a contract in the root directory, you simply just type a slash, and that refers to root. If you had these contracts in a separate directory, let's say the directory was called contracts, you would simply just type contracts here and the directory path would automatically populate. So you could just select the proper path. And we're going to click confirm, and the contracts within this directory automatically get populated here. So these are the contracts that you have for your solution. You'll see here there's also a button that says add inheritance. As we saw before, test company inherits from company. We saw that in the code, so we'll just simply add that inheritance. Since there's only 2 contracts in this directory, company is automatically populated here. But if you had to select from some different contracts and some different inheritances and maybe a more complex file, you could use this drop-down menu here and select the correct contract to inherit from. So as we mentioned, the testnet requires test files, functional testing files for each scenario. And basically what a scenario is it's just, it's basically some problem statement that you need to solve with your code. So for this project, we've created one scenario called build a company, where basically you want to make your own company, and the functionality should be to make someone an employee, have the employee log hours and allow the employee to see how many hours they've worked. You can also add any additional functionality you want. Just provide exactly where you can, what functions are doing that, and you could add that here. So we're going to go ahead and add 3 operations, or basically 3 functions, to solve this scenario. And you see I'm selecting test company, the contract, rather than company, because once again the testnet requires that you use the test contracts in order to run the code. It's basically the test contracts, they basically just specify the logic that you would expect a regular user to go through when using your smart contract. So that's why we require the test contracts, just so you can kind of write out that logic and it's all pre-written. So we do have 3 functions. The first one is called test add employee. The second one is called test log hour. And the third one, as we saw before, is called test get hours logged. And we'll go ahead to the next step. And here you can just kind of see a summary of the information you filled out. Please review this to make sure it is all correct and as you expect. Here you can see there's 2 smart contracts. You have the path to the file, the name of the file, and you can see here test company inherits from company. So that's all correct. And then here the functions that you specified in the given contracts to solve the scenario are listed out as well. So we will go ahead and hit confirm and submit normally, but since we're setting up a entirely new blockchain for every submission to evaluate it, it actually takes a little bit of time. So what we actually did was we made a submission earlier just so we could get the performance results and see exactly how this submission did. So you can see here, there's a lot of different metrics for this demo company contract. And when you click on the contract, you can see some more detail about it. So here you have the team name, the link. In this scenario, you can see this scenario here, it was a success, it means it passed. So you can actually click on it, and now you can get a lot more information as to the actual performance of your contract, which is pretty interesting. You can see some information such as scalability, latency, throughput, transaction fees, and you get some graphics as well just to show exactly how your submission is doing. Here you can see as the network size grows, how the submission performs with some different metrics. And then also here, as the workload level increases, as there's more traffic on the network, you can see exactly how your submission performs. So it's very comprehensive. It gives you a lot of information about the actual performance of your blockchain solution. And this is very comparative to a real world environment as well. So right before you deploy, it's good to use a tool like this just to see exactly how strong your solution will hold up in the real world. So that was the demo right there. So I think we'll go ahead and take some questions now. Yeah, we'll go back in the slideshow. We'll go ahead and take some questions now. That was basically a summary of Smart Contracts 102. Let us know if there was anything that we didn't make very clear and you'd like us to specify a little more. Also, if there's something that we didn't talk about or only briefly mentioned that you'd like to hear us talk about more, you can either ask us now if it's a quicker question, or maybe make a suggestion to us for a future webinar. It's maybe something we can go into a little bit more detail. So yeah, that's we'll start. So we have one question here. Yang asked my question: what makes testnet different from other testnets? If you think so, I don't know. Hoyan, do you want to?
Yeah, sure. So what makes our testnet different from other testnet? If you really think about it, testnet is not, well, our BlockTEST testnet is different than a traditional testnet in the sense that it's not really a testnet in the sense that I know that was a really mouthy response, but so compared to a traditional testnet, traditional testnet is public, so that means everyone can go on it and no one gets to really see when a smart contract is deployed, what kind of metrics was there. You can't really control how much workload goes to there because that depends on how many people are actually using the testnet and what they're doing. So our testnet offers, in compared to a traditional testnet, you can almost say we make a new blockchain every time you make a submission where people can just where the environment will be really stable since we're making it from scratch. And whenever you submit a solution, we will evaluate it and we can get to see all sort of different statistics because since we control the environment that we created, we can control how much workload goes into there, how many nodes there are. So yeah, in comparison to your traditional public testnet, that will be something that a public testnet could not offer. And if you just go back to the slide that we had earlier, we talked about the advantages of BlockTEST testnet over traditional testnet. And over here, you can see a full list of what we went over. So yeah, like we said, you can do a different workload in our testnet. You can change the network sizes. We can also show you different statistics and visualization on different testing variables, such as workload, network size, throughput, latency. We also keep track of CPU and RAM. And after all, our testnet is really simple and safe to use. So it's really friendly to novice smart contract developer who want to see how their solution would actually work in the real world environment compared to a traditional testnet where there might be multiple configuration files they need to fill out. In our testnet, it's basically a simple click and drag thing, and you just have to fill out simple form. And yeah, basically that's what our testnet offers. Great. So if anyone is listening to this as a recording and you want to ask us any questions, any suggestions, or just want to see future contents that you want to see, you can just send us an email and okay, so yeah, let me just go back to the slide here. Oops. So yeah, if you have any questions, you can feel free to send it to contact@blocktest.net. We can also visit our website, blocktest.com.net, whichever. You would go to our home site and you can fill out forms and just give us any suggestions. And if you want to see us in the future, definitely make sure to put in topics that you're interested in. All right, thank you for coming to this webinar. We will end it here and hope to see you in the future.